In this video, I will introduce Firecrow, a tool for client-side web application analysis and reuse. A central concept in Firecrow is a client-side feature. For example, this web application has at least two features. The first feature is related to this part of the page structure. When a user hovers with the mouse over it, this information box and these arrows appear. When the user clicks on these arrows, the application responds with its sliding effect. The user can also click on thumbnails for a similar effect. The application also has a second feature which manifests on this part of the page structure. When a user clicks on these labels, articles not described by the label disappear, while the remaining ones are rearranged. In short, we consider that a client-side feature is a subset of the application's behavior triggered by sequences of user-generated events that manifest at runtime with changes to parts of some application structure. The main purpose of Firecrow is to support reuse of client-side features. For example, if we have a web application with some features, for example this feature, when you click on these arrows, there's a fade-in, fade-out effect between different images, or when you click on these arrows, there's a sliding effect between different images. And now, if we want for the development of this application to use a feature that was previously developed in another application, for example, the second feature from the first example application. And we want to obtain something like this, a new application which has all the features that were already there, plus this new feature which looks and behaves exactly as it does in the original application.
Firecrow can be integrated into Firefox as a web developer tools plugin. The first Firecrow functionality that I'm going to demonstrate is feature identification, identifying the code related to the implementation of a particular feature. We can test the feature identification process on a simple example. In this window, I can write any HTML, CSS, or JavaScript code. For example, I'll put in there a code of a simple web application which calculates and shows the sum and the product of an array of numbers. So here we have some CSS styles which define the presentation of the application, some HTML code which defines the structure of the application, and some JavaScript code which defines the behavior of the application. By running this application, I can see its output. Now, if I'm only interested in part of the code which deals with calculating and displaying the sum of the array, I can select the HTML element which shows the sum and start the feature identification process. Here you can see that the tool has highlighted all code expressions that are related to this feature, both the CSS styles, the HTML code, as well as the JavaScript code which contributes to this feature. I can even do it a bit more fine-grained. For example, I might be interested in code expressions that contribute to the value of the variable product. So in essence, here we do web application slicing across three different languages: HTML, CSS, and JavaScript.
We can take this functionality to the next level by using it on more complex features. For example, this application has a feature that enables toggling between different images and captions. In order to identify the code responsible for this feature, first we have to specify the part of the page structure where the feature manifests. In this case, this is the HTML element with the ID slider. So we specify it as a slicing criterion. Next, we have to record an application execution in which this feature manifests. So we press the recording button and demonstrate a usage scenario. Now we can start the feature identification process. After some time, the tool has analyzed the application and we are shown the code that is necessary for the implementation of this feature in this particular scenario. We can save this code and we can study the result. So we can see that the feature behaves exactly as it did in the original application. The feature identification process relies on the existence of usage scenarios that cause the manifestation of a particular feature. Sometimes specifying these usage scenarios can be a difficult and time-consuming activity. For this reason, we offer the functionality of scenario generation. For example, if we have an application which has several high-level features, one of which is that you can select between different options in this combo box, which changes the situation in the map. You can click on different buttons to change the images on the right-hand side, and you can toggle between different images by clicking on these buttons or by using the keyboard shortcuts. In order to generate sequences of actions that target this feature, first we have to specify the part of the application structure we are interested in. In this case, we are interested in this central part of the application, which has the ID central container, and we are also interested in this right-hand side part, which has the ID location feature container. Next, we simply start the scenario generation process, which will explore the value and the event space of the application. After some time, on the right-hand side panel, you can see all scenarios that the application has generated, as well as the scenarios that the process has determined as important for the feature. Finally, in order to achieve reuse, we have to specify the page from which we want to extract the feature. We have to specify the feature location, as well as the page where we want to reuse the feature into, and the position where we want to put the feature. Next, we simply start the feature reuse process and wait. Finally, after some time, the reuse is achieved. We can save the result and we can study it. So the features that were already there behave in the same way, and this new feature behaves as it did in the original application. This has been a short demo of Firecrow, a prototype tool for web application analysis and reuse, which is openly available at GitHub.